Hi everyone, thank you for being here at our press event about all things shipwreck science here at the Ocean Sciences meeting in New Orleans. This press event will be recorded and posted to AGU's YouTube channel later today. Feel free to share that widely. We have three panelists today with us: Melanie Damour from the Bureau of Ocean Energy Management, Nathan Figueredo from Louisiana State University, and Kirsten Meyer-Kaiser from WHOI. To kick us off, Kirsten is gonna just give us a brief excitement introduction to get us going, and then we'll turn it over and begin our presentations. Sure. Oh, you can just use that one.
Yeah. Okay, it seems the microphones are on.
Yes.
Thank you. Can everyone hear me if I talk like this? Okay. So yeah, thank you so much for coming today, and we're really excited to talk to you about all of the interdisciplinary facets to shipwreck research. So I'll just call out this photo because Becca put it up. That is at 70 meters deep off the coast of Bonaire, and that's a 19th century anchor that I'm next to. Covered in sponges, covered in sea fans. So right away you can tell any anthropogenic object that we put into the ocean eventually becomes a habitat. And that is absolutely the case for shipwrecks. So a wreck not only has all of the history associated with it, the story of the disaster or the lives lost that are associated with that, but also it becomes part of the environment. There's a two-way feedback between the wreck itself and the environment around it. One archaeologist who I collaborate with regularly, Calvin Myers, likes to say that a shipwreck you can think of just like an artifact in any historical museum, except that it's not roped off or behind glass. It's subject to erosion, it's subject to wave action, corrosion, all of those things. And so what we really try to do is understand all of those multifaceted interactions between the wreck itself, the physical environment, and the biology that influence that site over time. And I'm hoping the next slide here, nope, that's Melanie's talk.
Yes, sir.
Okay, so today we have multiple aspects represented. I'm a benthic ecologist. I study seafloor communities. I'm especially fascinated by things that are isolated and island-like, which is how I ended up looking at shipwrecks, because by definition, they are not supposed to exist. Melanie on the far right is a microbiologist, and she can give us an introduction to some of her work.
I'm an archaeologist.
But you work on microbes. We are all everything. And Nathan will be able to talk about some of the sedimentary patterns as well. So should we go into that portion? Okay.
Ooh, I get the clicker. Uh-oh. Good morning, everyone. I'm Melanie Damour. I'm a marine archaeologist with the Bureau of Ocean Energy Management. I'm the environmental studies coordinator for our Gulf of Mexico region office based here in New Orleans. And so I want to chat with you guys kind of briefly about who BOEM is and what we do. We are a regulatory agency within the Department of the Interior, and we have a robust environmental studies program that funds the research that we need to inform our decision making. So we are not like the National Science Foundation, who funds science for the sake of science. Our research is very specifically focused on what our information needs are. But the great thing about our studies program is that over the past 50 years, a lot of that research is able to percolate out into other information needs for other agencies, and also to help address some broader ocean science questions. So I want to give you just a couple of examples of some of the research that we've done that was specific to BOEM information needs, but has a wider application to ocean sciences. There we go. So shipwrecks as artificial reef habitat. 20 years ago, BOEM funded a study looking at deep water shipwrecks as artificial reef habitat and examining the macrofaunal communities that reside on them. So in other words, do shipwrecks serve as artificial reef habitat? And how important are they in areas of the deep water environment where there's very little natural substrate available? One of the interesting things that we found was that by integrating the archaeology, which is looking specifically at the shipwrecks themselves, that's what I do, and the biology, looking at the biological communities, the archaeology can help inform the recruitment time for biologists to help understand, well, how long has this substrate been available for colonization, and how old could these corals and sponges be? So that really started to pique our curiosity about other interdisciplinary studies that we funded over the years. But we've also found that shipwrecks can help inform broader environmental questions. And we funded a study in the wake of the Deepwater Horizon spill back in 2010 that looked at impacts to microbial communities residing on shipwrecks. Microorganisms are a key component of establishing an artificial reef habitat. They are the first to colonize these sites, and they're the ones that allow larger organisms to eventually settle over time. But they are also part of the process of wood degradation and metal corrosion over time, so we really wanted to understand what that looks like. And one of the things that we found was that spill impacts affected the microbial communities, but that also in turn affected metal degradation. The example you can see on the upper left, that is showing a 2003 photograph of the German U-boat U-166, which sank in 1942. The areas in red, that is the metal degradation that occurred after the Deepwater Horizon oil spill. That image was from 2013. So we definitely have information about how broader environmental impacts can affect these types of cultural resources. We've also looked at other types of impacts, such as hurricanes, and one of the interesting findings of this particular study was that hurricane damage tends to be focused in areas where the shipwrecks were previously damaged. So what that tells us is any sort of physical damage that occurs on the shipwreck could be exacerbated by other activities that happen, not just human activities, but natural events. And one of the cool things was we found that through modeling efforts that shipwrecks during peak storm conditions can be subjected to forces similar to a tornado on land. So think about that for a minute. So there are a lot of different things that can affect these shipwrecks over time. We're also using shipwrecks in new and innovative ways, and this is a study that my colleague Nathan is going to talk about in a little more detail. But we are looking at how the movement of shipwrecks over time through mudslide events can help us track these mudslides. Off the coast of Louisiana, this particular area is prone to underwater mudslides. And we are using shipwrecks in a very innovative way to help track these events over time. The example that I have here is the tanker Virginia, which was torpedoed by a U-boat in 1942. This is a 500-foot-long steel-hulled freighter. A tanker. This is not a little fishing boat. This is a massive piece of human equipment that is on the seafloor. And it has moved almost 11 kilometers over the past 80 years because of these mudslide events. And what we found that it's entrained within a mudlobe. It's not moving independently from it. So a lot of the research that BOEM has funded over the past 50 years is not just for our information needs. It is helping us address some of these broader ocean science questions. And we are very excited to see where this is going to take us forward in the future.
Can everyone hear me okay? All right, so I'm Nathan Figueredo. I'm a PhD student at LSU, and I'll be talking to you guys a little bit more about the Virginia shipwreck and its mudflow lobe. So for those of you who are unfamiliar, this block model helps me kind of show what a mudflow lobe might be. So we got a couple examples present here, and essentially what we're looking at are fluidized sediments sitting on the seafloor, flowing downslope at various rates. So here you can see what an actual lobe looks like. This is the Virginia lobe. We have the shipwreck previously mentioned right in the center there, that black smudge looking thing. There's the Virginia pointing straight to it. So why might this be important? Well, we have abundant infrastructure in the Gulf of Mexico that's vital to economies and ecosystems to maintain. This is an image showing pipelines and platforms just in the vicinity of the Mississippi River Delta front, which is kind of a hot spot for these lobes. Historically, these lobes have shown capabilities to completely topple platforms and disrupt pipelines, and those lobes didn't have a 500-foot oil tanker conjoined to them. So looking at a little bit what we did, here we have the lobe again in the center, and the great thing about having a shipwreck conjoined to your lobe is that anywhere that shipwreck goes, the lobe also goes. So in using this shipwreck tracking data from 2004, we can see on the right from 2004 to 2017, along with bathymetric data and sediment properties from core data, we were able to estimate mudflow movements. Results from these calculations showed that mud flows are moving sediment downslope at rates faster than that can be resupplied from the Mississippi River. So taking this information, we kind of developed a new hypothesis for how sediment is distributed over time on the Virginia lobe. So looking at this top figure, we have sediment accumulation rate versus distance. On the left, we have inshore, and on the right, we have offshore. So basically what this is showing is that as sediment accumulation rates decline over time, we're seeing greater effects on the inshore. The lower image is showing how sediment might transition over time downslope. So we see the inshore sediment migrating or flowing downslope. And since sediment rates of the Mississippi River are in decline, we're not seeing enough sediment accumulation at this region to resupply that sediment inshore. So essentially our mudflow lobes are migrating downslope with no resupply to replenish them. If this hypothesis is supported, we will see reduced hazards regarding mudflow lobes in the region, and we plan to extend this project over the next couple years to various other mudflow lobes across the Mississippi River Delta front.
So getting into just a few more examples of how shipwrecks can be used for interdisciplinary research. This is a framework actually that I co-designed with an archaeologist I collaborate with. We call it maritime heritage ecology, and that multisyllabic mouthful is meant to just encapsulate the umbrella of all of the ways in which we can understand the role that shipwrecks play in the environment and how environmental factors influence those shipwrecks in turn. So the example here is a steamship, the Portland, that sank in 1898 with about 200 people on board. We decided to use it as the basis for this graphical representation. That shipwreck is located in Stellwagen Bank National Marine Sanctuary. And so the central tenet here of maritime heritage ecology is that two-way interaction between the physical structure of the shipwreck and the environment around it. So there are larvae from other naturally occurring hard-bottom habitats that can disperse to the shipwreck, colonize, and create a community. Very often we find that the community on the shipwreck significantly varies from what you find on adjacent naturally occurring, for example, boulder reefs. I think that comes down to the open niche space. Sometimes rare species can thrive because of the microhabitats provided by the shipwreck. But over time, you have the shipwreck disassembling, basically. This is called site formation processes in the archaeological lingo. And so basically it's breaking down. And that influences the range of microhabitats available on the shipwreck, which in turn can serve as a stepping stone for some of those species to spread elsewhere. The final thing that I've put on here is anthropogenic influence. Through my research in Stellwagen, we actually uncovered a really strong impact of commercial fishing on the shipwreck structures. The example of the Portland here, we had two different fishing impacts. The fantail stern got ripped off and a new net got entangled on the port bow sometime between 2009 and 2019. And our research showed that those fishing impacts also translated into the biological community that was living on that shipwreck. Because we're located here in New Orleans, I wanted to touch on a project that I've recently done in the Gulf of Mexico in the mesophotic zone. This was actually a collaboration with BOEM. So I'm showing two example sites here that we investigated as part of that project. The CP Baker, which is actually a mobile oil drilling rig that sank in the 1960s, and one of our natural hard bottom sites. This is just a pile of rocks. And the CP Baker and many of the shipwrecks that we investigated in that study had clearly higher biodiversity, much higher species richness, much higher density and abundance of organisms. I was particularly looking at the invertebrates, and I also did an analysis of the fish communities for this project. And that's just because of the heterogeneity of the habitat. You can see the CP Baker's got those two giant pontoons, it's got some complex lattice work connecting them, and a lot of organisms thrive in those small habitats. Whereas in our natural boulder reef, you do get things living on the rocks, but it's not nearly quite as complex and doesn't stand nearly as high off the seafloor. So it's a very different community. I do want to point out a little bit of the dark side of that higher biodiversity, which is that shipwrecks can facilitate the spread of non-native species. I found two on the C.P. Baker and many of the other shipwrecks in that study. You can see one in that top image and one in the lower image, the sun coral, which loves to live on the underside of structures, was much more common on shipwrecks because they provide that microhabitat, the underside of an overhang. And also a small reef fish was rather abundant on the shipwrecks. Those are both Indo-Pacific species that have spread throughout the Gulf of Mexico, in part because of using shipwrecks as stepping stones. But then finally, I am also of the opinion that anthropogenic structures, particularly shipwrecks and things that have been in the water for a long time, can inform our understanding of future ocean sprawl. And by ocean sprawl, I'm referring to offshore wind, any hard structures that we put along our coastlines. This is an example of 2 sites in Palau that I have recently started studying. You can tell that World War II shipwreck on the left has a lot of corals on it, versus the airplane on the right is relatively empty. And I'm testing the hypothesis. This is very preliminary stages, but I believe that this might have something to do with the trace metals in the water. So those graphs that I've got on the bottom right there are trace metal concentrations in coral tissue for one of the more common species. And you'll notice on the steel shipwreck, you get much higher iron. On the aluminum airplane, you get much higher aluminum. Well, guess what? Aluminum is toxic, whereas iron can be an important cofactor for key enzymes in coral physiology. So this is a future avenue that I think deserves a lot more investigation. I believe that is the end of our slides, and we will be happy to take questions.
Yeah, so thank you to our panelists. This is a roundtable event despite the linear tables in the room. So we can feel free to keep it pretty conversational, pretty low-key. For our reporters who are online, you can either put a Q&A, or you put a question in the Q&A box and give us your name and outlet, and we will read it to the room for you, or just put your name and outlet, and we will unmute your microphone, and you can ask it to the room. And for reporters, please, just introduce yourself if you're on the microphone. So yeah, we can kick it off. Any questions in the room?
Okay. Tristan Bowrick, Times-Picayune. Nathan, I was a little confused. So are the hazards increasing in the Gulf of Mexico from landslides, or are they declining because of the sediment that's coming out?
So if what we're saying is correct, where we're having these lobes not be replenished in their nearshore processes, and they're just migrating outwards, eventually that hazard will be diminished because those lobes will just continue migrating until they're out of the picture, essentially.
Great, thank you. That's it for me.
I actually have a follow-up question while we wait for anything else about the timeline of that. So if it is decreasing, do we have a sense for how quickly this hazard might be decreased? Like, are we talking years, decades, centuries?
I think that would be something that we are going to look into in the future in expanding this study. This is kind of a fresh idea coming out of my master's work, moving into the PhD work. So it's not something we've necessarily looked into right now, but it will be in the future.
Okay, keep your eyes open. And then, Tristan, do you have anything? Okay. And then we have a question for Melanie, which is, as we've seen here, the shipwrecks or the science around shipwrecks can be so interdisciplinary, and so a lot of people might be interested in maybe incorporating this or exploring how they might collaborate. So is there anything in particular that science should be considering, either from a scientific or regulatory standpoint, if they're looking to get into this?
Yeah, I would say there are definitely some things to consider. As an archaeologist, my focus is on the shipwreck itself. And we are trained as part of our education how to investigate these shipwrecks non-intrusively and intrusively as well, and in ways to minimize or eliminate any damage to them. Shipwrecks are a non-renewable resource, and every single one of them is unique and has its own story to tell. So when we study them, we need to make sure that we're not causing any damage that might hasten their degradation over time. Archaeology is also, it's ripe for integration with other sciences. A lot of what we do borrows from, economic theory, anthropological theory, biological theory, physical theory. So integrating all of these different sciences together is absolutely critical. But, with, say, for example, a biologist who wants to go study a shipwreck, not putting Kirsten on the spot here. I'm not talking about Kirsten. But if someone wanted to go sample sponges from a shipwreck, I would say that a particular project like that absolutely must have archaeological oversight. Because, folks can get tunnel vision on their science, and if, they're looking at sampling something from a shipwreck, there could be damage caused from that. And so a lot of the work that we do out in the field, there are a lot of discussions that take place. For example, a biologist wants to sample a particular type of sponge, and we could say, well, there's one over here that's on the wreck, and then there's one over here that's on a ballast stone. So let's go sample from the ballast stone because you're not going to damage that, whereas you might with the wreck. Same thing with sediment coring. We want to make sure that sediment cores aren't being collected in debris fields that might contain artifacts. Another very important component, especially with deep water wrecks, is that everyone needs to sort of have the assumption in their head that there might be human remains on board. And I think a lot of folks outside of archaeology don't consider that component. And so an archaeologist can help provide that sort of background, like, okay, we need to be careful and consider that this potentially is a mass grave. So I don't want to open Pandora's box and say, yes, everybody should go study shipwrecks. There is a lot to offer scientifically, but the archaeological oversight must be present to make sure that no damage is done to these wrecks that, will be detrimental to future generations who might want to study them as well.
And I guess just to follow up then, not all shipwrecks are, some shipwrecks are in international waters. They may be claimed by multiple countries or, entities. So I would be interested to hear a little bit more about, like you were saying, maybe there needs to be archaeological oversight, but how is it determined, which ships or vessels are left alone, which are pulled back up, like Amelia Earhart's plane, they're talking about potentially, pulling back up some private company. So I'd just be curious to hear a little bit about, like, how those decisions are made and who can have the final say.
Right, so legally it's a very complex discussion to have. Every nation has their own laws related to historic preservation. Generally, at least from the archaeological standpoint, we consider anything older than 50 years to be, archaeological or historical. Anything less than that is considered to be modern, so there's not archaeological value there, but there is for biological study. So another factor is also ownership of wrecks. Navies continue to own their own vessels long after they've sunk, and they are still foreign flag vessels if they're in U.S. waters, for example. So the German U-boat is still the property of the German government. So there are legal protections that we have. We have the Sunken Military Craft Act, for example. So any work on naval vessels or foreign flag vessels in U.S. waters must be, you have to get a permit to work on those types of wrecks. But in many cases, with a lot of the older wrecks, we have no idea who they belong to. So we have to keep that in mind, that this is something that could turn out to be the property of a foreign government. So it's a very complex legal situation to consider, but it's always best to err on the side of caution and not just go out and decide to go investigate a shipwreck on your own.
Thank you. And we have a question for Nathan, and maybe Melanie could also touch on it. For the mudlobes, how quickly are they moving? And if there is a vessel like the tanker that you were looking at on it, and we see that it's moving towards a structure, is there anything that we can do about it? If the structure that it's headed towards is immovable, like what is the response when you see that?
So as far as how quickly they're moving, it's probably a case-to-case basis, but in the instance of the Virginia lobe, based on our calculations, the entire lobe could evacuate over the course of anywhere from 7 to 1,400 years. It's really just identifying these triggering mechanisms, and the hazard comes from, if it moves over 1,400 years, that's not a big deal. But if a hurricane rolls through and those waves kind of cyclically unload the sediment, and we have an instantaneous shift of millions, 100 million metric tons of sediment, that could be catastrophic. So.
We have a question from an online reporter. Freelancer Danielle Berteau asks, could anyone, further to the commercial fishing damage issue, are there any moves to protect these wrecks? For example, something like a special type of MPA. Is that a good idea?
So the commercial fishing damage that I was showing in that diagram on the Portland actually sits in Stellwagen Bank National Marine Sanctuary, which is an MPA. But because it's in New England, you can't possibly outlaw fishing from any area in New England without massive cultural backlash. So fishing is permitted in Stellwagen. And this has been kind of a core piece of the sanctuary's management since its founding in 2002. The sanctuary's policy up until now has basically been to keep all of the wrecks locations secret. I actually had to sign an NDA before we were allowed to do the research. They considered that the most likely source of damage to the shipwrecks was looting by divers. And so all of those locations were kept secret in an effort to make them all as pristine as possible. Our research in part showed that commercial fishing is a more pressing threat to the structure of the cultural resources in Stellwagen than scuba divers as anticipated. So in partial response to that research and some other things going on at the time, the sanctuary has now undertaken a pilot program. They're calling it the Shipwreck Avoidance Program, where they released the coordinates of a small number of shipwrecks as a pilot study, and they asked fishers to avoid a certain radius around each of those released locations. And then they undertook a rather ambitious effort interviewing the captains of fishing vessels to assess levels of compliance, attitudes towards the program, et cetera. So far, it seems to be working. And so we're actually, my team is in the process of co-writing a proposal with Stellwagen staff to try and continue connecting with the fishing community, having roundtable discussions, and eventually with the goal of building up a collaborative, community-based set of policies that would allow fishing and maintain that great New England economy and heritage while protecting the shipwrecks to the greatest extent that we possibly can.
Kristen, then I might ask you, I'm curious to hear a little bit more about how we define ocean sprawl and sort of how widespread a problem it is. Like, for example, in the Gulf, like, do we know how many sunken vessels there are? How well do we know that? And sort of related to ocean sprawl and, the opportunity that these vessels can have to provide habitats both for better and worse. Could we view ocean sprawl as, a net benefit for the seafloor, or is it more of a silver lining on an anthropogenic problem?
So that was a multi-part question. So in terms of how many shipwrecks there are in the Gulf and how we know that, I need to defer to Melanie. Do you want to jump in?
Sure. Yeah, so in the Gulf of Mexico region, we funded a number of studies over the last 50 years that have compiled a lot of archival information on historic shipwreck losses off the coast, but we also require industry to conduct surveys of their areas before conducting seafloor disturbing activities. So we've added new shipwrecks to our database, and right now we have almost 3,000 that we know of. However, history being what it is, not all vessel losses were reported, so there could be many more than that just in the Gulf alone.
The second part of that was defining ocean sprawl and whether I think it would have benefits or damage biological communities.
Yeah, sort of, is it more of like a net benefit, or we're just looking at ways that it can benefit, but it still might be sort of a net negative overall impact?
Yeah, so this is going to verge into the realm of personal opinion rather than scientific data. So with that ginormous asterisk at the beginning of this, so let's start by defining ocean sprawl. I personally define ocean sprawl as the construction of new anthropogenic habitats extending out into the ocean, essentially hardening our coastlines. And so this, in many cases, includes offshore wind, but also other installations. Living in New England, offshore wind is something that's very much on my consciousness because we're getting wind farms installed just south of Cape Cod where I live, and so that is definitely a piece of ocean sprawl. Okay. Going into my opinion, not necessarily 100% relying on scientific data. I tend to take a relatively positive view of anthropogenic substrates, structures in the coastal environment. It definitely has an impact in terms of hardening the coastline, altering sediment patterns, stuff like that. But for the organisms that I work on, and that's what shapes this opinion, it tends to provide habitat. And furthermore, the steel structures, for example, I showed that World War II shipwreck in Palau, seem to have a benefit for some really key species, for example, reef-building corals. I'm aware of at least one offshore wind company that's trying to see if their steel bases for their wind turbines could be used as additional coral habitat. And so in my mind, having anthropogenic structures is like getting a net benefit out of them. It's just a matter of proper design and making sure that there's science at the table so that we can have that conversation and make sure that we are providing habitats for key species. Another potential benefit is that in some cases, for example, a wind farm could turn into a de facto MPA because fishers don't want to be going through there because there's so much stuff on the seafloor. So I personally, again, this is opinion, not 100% grounded in data, see a lot of positives to that, but I should open it up to the others to have more nuance.
Sure, I can add to that a little bit. I would say from an archaeological standpoint, shipwrecks aren't just a tangible reminder of past human history. They're an inextricable part of the marine environment now, and they're providing habitat in important places where natural substrate may not be available. So I think from that standpoint, from a scientific standpoint, there is a positive benefit. You can look at shipwrecks as laboratories under the sea, helping us address broader ocean science questions. Really shipwrecks could be found anywhere. I mean, there is a degree of randomness to their distribution. You need water and you need a catastrophic event of some kind that causes it to sink, and that can literally happen anywhere. And what scientist doesn't like a random sample? So there's that.
Sort of a follow-up to that question about net benefits and things. Just thinking about climate change's impacts on the ocean, things like acidification and then sort of the 1-2 punch of marine heat waves and cold spells. Can those climate change impacts have any negative effect on the physical structures of the ships, like breaking them down more quickly, that sort of thing?
Yeah, so I'll start with the example of Stellwagen again. They are terrified of shipworms showing up in the sanctuary. As temperatures warm and many species expand their geographic ranges more towards the poles, there's the potential for teredos, which are relatively warm water shipworms, making their way into Stellwagen and having their way with all of the wooden shipwrecks. So that's definitely a concern. In terms of metal structures, ocean acidification can increase the corrosion of metal shipwrecks. I know that temperature also plays a role in that, and I'll invite these guys to also comment a little bit more. In terms of climate change impacts on shipwrecks, I would direct everyone actually to a fantastic paper written by Geneva Wright. That was, I believe it was published in the Journal of Maritime Archaeology. And so that delves into a lot of those issues that we are just now starting to understand.
Do you want me to follow up on that? Okay. Yeah, speaking from the metal degradation standpoint, metal corrosion in the marine environment, it's a biochemical process. So you have the actions of biological organisms, your microorganisms, but it's also the chemistry of the water itself. Anything made of steel does not like salt water. That's just a fact. So that whole corrosion process is inherent anytime you put something in the marine environment. And any changes in that chemistry, temperature, dissolved oxygen, all that can certainly have effects on metal corrosion itself. So yeah, that is definitely something that we're keeping an eye on for sure.
On the topic of invasive species kind of using these as sort of hopping around and moving around, what's the balance of the positives versus the negatives? I mean, it's great for some species, but is it offset by the spread of invasives?
That's an extremely good question. I would say that there's multiple dimensions of nuance here that need to be acknowledged, one of which is how bad is the non-native species. I say non-native because there's a difference between non-native and invasive, invasive being something that is a detriment to the ecological system around it, or has very rapid dispersal, very rapid reproduction type of thing, and kind of just wreaks havoc. So zebra mussels are an example of an invasive species. In terms of the sun coral and that little reef fish that I showed for the Gulf of Mexico, I don't think that they cross the line into invasive, and I'm kind of hedging as I say that just because I need to read a little bit more literature, but having looked into it relatively recently, there was nothing that emerged as, oh, this is a clear, horrible ecological impact of that particular species. So in the case of that Gulf of Mexico study, I would say, sure, we're facilitating the spread of a non-native, but for that cost, we are getting habitat for all sorts of fantastic species that we really do want to preserve. For example, the CP Baker, being at about 50 meters in the mesophotic zone, provides habitat for reef-building corals in an otherwise fragmented habitat where they're a little bit more sheltered from stressors at the surface like high temperatures. My personal calculus puts that on the net benefit, but again, I think it comes down to the non-native species that you're dealing with and what could be the potential impacts of that.
Thanks.
Okay, in our last couple minutes then, I'd love to hear from each of you. So in your sort of respective areas of focus within shipwreck science, what do you think are the hottest topics, the most exciting or interesting things that the community is working on that might be coming out in the next sort of like 2 to 5 years? Like, what is the exciting near future for shipwreck science?
I guess we can go down? Sure. Okay, so to me, the most exciting direction is understanding the multi-directional interactions, specifically between the physical structure of a wreck, the microbial community on it, and those larger animals like the invertebrates that I like to work on. One of the things that I am trying to do over the next 10 years is use the lagoon of Chuuk, which is in the Western Pacific, as a natural experiment. This was the site of a World War II battle, and literally if you gave me $1 billion, I could not design a better experiment. We have about 50 ships and over 200 airplanes that all sank within 3 days of each other at scuba diveable depths. So I think that is a great case study to answer what I consider to be the most important question of what is the three-way interaction between the physical structure of the wreck, the metals that it's composed of, the three-dimensionality, the microbial community that might be using some of those trace metals or microhabitats, and the larger organisms, including reef-building corals, and furthermore translating that into what does that tell us about other anthropogenic structures in the ocean, and how can we use things that we would probably be doing anyway, like building wind turbines, to help protect biodiversity and sustain a changing ocean.
So I guess I'll be a little selfish and say, look out for our next paper in a couple years. But really, we're doing a lot of cool stuff. Essentially, the subaerial bird's foot has been accepted to be retreating for a while now, and what we're looking at is the foundation of what all that land builds on in the subaqueous. And we're using shipwrecks to decide whether or not these are diminishing greatly and whether or not we can get any sort of land building out of that area, or finding out really what's going on. And in the future, hopefully we'll be including other shipwrecks. We have a couple locations we're going to check out and try and expand how we can use them.
So speaking from the marine archaeological standpoint, I would say broadly, marine archaeology is definitely going to continue with these interdisciplinary integrated studies, working with scientists from other disciplines who can help us understand what's happening on these shipwreck sites. We're using all kinds of cool technology, 3D laser scanning, 3D sonar scanning, and 3D photogrammetry, which allows us not only to measure change over time, but to create these really cool digital models that can be shared with the public, and they can explore a shipwreck from the comfort of their lazy boy. So technology is definitely something that we're going to continue incorporating into our research. Personally, in looking back over the last decade of some of the work that I've been involved in, using shipwrecks as ecosystem monitoring platforms after major events like an oil spill, I think is giving us a lot of important information. And now using shipwrecks as sentinels for seafloor movement and mudslides is a pretty cool way of using them in new ways. But looking forward, I think we can also use them as sentinels for climate change and coastal shoreline change. Some of the research that I did way back in the day in grad school looked at barrier islands. And I know of a couple of cases in Florida where the islands are now moving away from shipwrecks that we previously investigated that were right on the shore, 20 years ago. So I think expanding into climate change is going to be another way that we can innovatively use shipwrecks to answer some of these larger questions in science.
Great, thank you. Any more questions online or in the room? Okay, with that, I will again thank our great panelists for sharing all your excitement and information with us today. As I said, also this recording will be posted to AGU's YouTube channel and shared out on social media. And thank you all for joining us at the panel and at Ocean Sciences meeting.
Thank you.